The following table shows the when to use which statistics. When population distribution is known. Population distribution, okay, population standard deviation, sample size n, and the statistic. Clear? So if it is normal, if the population distribution is normal, and if the standard deviations, population standard deviation is known, and sample size is more than 30, okay, more than 30, yes, then we have to use Z statistic. Okay. Similarly, if it is normal and if it is known and it is less than 30, then also we can use Z statistic. If it is normal, if it is unknown, and if it is more than 30, then we can use Z statistic. And if it is not normal, okay, now see, if it is not normal, population distribution is not normal, but population standard deviation is known, okay, and if the size is more than 30, then also you can use Z statistic. Okay. Now if it is not normal and if it is unknown, and if the sample size is very large, more than 30, then also you can use Z statistic. But if the sample size is population distribution is normal, okay, and population standard deviation is unknown, and sample size is small, say less than 30, then we have to use T statistic. Okay. But if it is not normal, okay, not normal, known, and sample size is no, so we can't use any statistic. Similarly, if it is not normal, if it is unknown, okay, and if it is less than 30, then we can't use any statistics. Okay. If the sample size is big, then the estimates is pretty good, and we can just use the standard Z-test large sampling concepts, since we already know that if the original population is normally distributed and the sample size is large, then the sampling distribution of the mean of sample will also be normally distributed. But if the sample size is small, say 30 or less, then sample statistics follows students' distributions. In other words, if sample size is small and population standard deviation is unknown, then we use T distribution to address the uncertainty of the standard error estimate. That is called small sampling concepts. Now, what is small sampling concepts? The study of statistical inference with small sample is called small sampling concepts or exact sampling concepts. The large sample theory is based on the application of normal test, but if sample size is small, the distributions of the various statistics do not follow normality, and hence normal tests cannot be applied. In such cases, exact sample tests are used. The exact sample test can be applied to large samples, but the converse is not true. Type 1 error is increased if we apply large sample test, okay, for the small sample. Okay. Now, already you know that if it is Z, so for the large sample case, for conclusion or for decision, we use the normal curve for decision. Say it is 0. Say if it is Z alpha by 2 minus Z alpha by 2. Clear? So whatever may be the technique, we use normal curve for decision. Now, if the sample size is small, okay, and if population standard deviation is not known, then for decision we use a figure like this way. Okay, so this one is greater than equal to 30, so it's a normal curve. Now assume it is n2, okay, it is n3, it is n4. So size of 1 is greater than size of n2 is greater than n3 or greater than n4 and so on. Okay, so if size increases, then thickness will increase. If size decreases, if the sample size decreases, the thickness will also decrease. So n1, n2, n3, n4, these are called degrees of freedom. Okay, these are called degrees of freedom. Okay, so the t distribution is bell shaped and symmetrical around the mean. So it's a bell shaped and symmetrical about the mean. The t distribution is less peaked at the center and higher in tail. So less peaked than the normal, so lesser peaked. Okay, then the normal distribution. The t distribution has more dispersion variation than the standard normal distribution. As the sample size n gets larger, the t distribution approaches the normal form. In other words, the curve of the t distribution is flatter than that of the normal distribution, but as the sample size increases, the t curve starts to resemble the normal distribution. So if n is increasing, if n is increases, then the thickness of the curve will also increase. This is nothing but our normal curve. Okay. The shape of the t distribution changes as the number of degrees of freedom changes. Shape will change as the number of degrees of freedom changes. Okay. For different degrees of freedom, the t distribution has a family of t distributions. Now, steps of hypothesis testing for small sample using t-test. Now, first is hypothesis testing of population parameters from small sample. Okay, so test or hypothesis about population mean. So first one, in this particular small sampling text, we will talk about the single mean. Next, difference of means, and third, paired t-test. Paired t-test. Okay, so first one, single mean. So parameter of interest, say mu. Second, we have to decide the level of significance alpha. Next, third, null hypothesis, say mu will same to mu a. H1 mu is not equal to mu a. So mu is the original population parameter, mu a is a assumed population parameter. Mu is equal to mu a, mu is greater than mu a, mu is less than mu a. Clear? So for two tail test we use this particular, for right tail test we use this one, for left tail test we use this one. Next, when the population distribution is normal and population standard deviation sigma is unknown, so under A0 the t statistic is, t calculation is x bar minus mu a by s by square root of n, where x bar is a sample mean, mu is a assumed population parameter, s is a standard deviation, sample standard deviation, and n is the sample size with n minus 1 degrees of freedom. Okay, and to calculate standard deviation we use the formula okay. And next is decision. So for the decision we use this particular, for two-tailed test it is t alpha by 2 degree of freedom n minus 1 minus t alpha by 2 degree of freedom n minus 1. Clear? For right tails this is for two-tailed test. So if the value in between this, so it is called upper critical value, this is called lower critical value. So if a value is in between these two, then accept H0. If it is more than this value or less than this value, then reject H0. Here reject H0. Clear? Next, if it is right tail test, then accept H0. Okay, so this is t alpha n minus 1. If the value is less than this particular value, accept H0. Here reject H0. If a value is left tail test, this is for right tail test. For left tail test, here minus t alpha n minus 1. Okay, so if a value is less than this, then reject H0, and if it is more than this, then here it is accept H0. Okay. Now one more thing is that confidence interval for the population mean. So confidence interval, next, the formula for confidence interval x minus t alpha by 2 n minus 1 is by square root of n. Okay, so this is our confidence interval, where x bar is the sample mean, alpha is the level of significance, n is the sample size, s is the sample standard deviations. And already you know how to calculate sample standard deviation. Prices of shares of the BBA company on the different days in a month of June 2015 were found to be 100, 120, 100, 105, 123, 103 and 1112. Test whether the mean price is 110 and calculate confidence interval for the mean price with 95% confidence. Now here we have to apply two-tailed test. So first example. So two-tailed test, assumed mean, okay, assumed mean it is 110, alpha minus 1 is 95%, alpha is equal to 5% or 0.05. Okay, now null hypothesis. Okay, null hypothesis what? Mu is equal to 110 and mu is not equal to 110. Clear? So if it is, so in H0 the mean price is 110, here the mean price is not 110. The data are 110, 100, 120, 105, 123, 103 and 112. Clear? So if you here we have to calculate the sample mean. So sample mean here 110.4286, and we have to calculate the sample standard deviation. The sample standard deviation is 8.6189. okay, sample size n is equal to 7 data are there, 1 2 3 4 5 6 7. Now under H0 the t statistic is x bar minus mu a is by square root of n. 110.4286 minus mu a, it is 110, okay, divided by s is 8.6189 divided by square root of 7. So if you solve it, you can get the value 0.1315. okay. Now next we have to see the table value. So if here degree of freedom it is n minus 1, okay, so 7 minus 1, that is C. Alpha is equal to 0.5, so alpha by 2 is 0.05. Now so since it is a two-tailed test, Okay, so t alpha by 2 means 0.25, because alpha is equal to 0.05, alpha by 2 is 0.025, 0.025 comma degree of freedom 6. Now you can see this particular table. Okay, here it is t table, sorry, but it's a t table. Now degree of freedom is 6. Okay, now degree of freedom is 6 here, so it's a 6, and alpha is equal to 0.025, so 0.025 is 2.447. Okay, so 2.447, here the value is 2.447. are you getting? So alpha is equal to in degree of freedom is 6, and here it is alpha is equal to 0.025. Okay, so the value is 2.447. so here it is plus 2.447, here it is minus 2.447, and our calculated value is 0.1315. so 0.1313, say it is 0, so something somewhere here. Okay, 0.1315, and it is in acceptance region, so accept H0 or do not reject the H0. Since the computed value is within the range, hence do not reject the null hypothesis, and we conclude that the mean price is rupees 110. Then when we have to calculate the confidence interval for population mean. Okay, so already we know the formula. The formula is t alpha by 2 comma v, okay, n minus 1 s by square root of n. So 110, so sample mean is what, 110.4286 plus minus 2.447 into 8.6189 by square root of 7. Okay, so 102.4575, 108.3997. Clear? So sample population mean will be within this particular range, more than this and less than that. So in this way we can guess the population parameter. Next problem. The mean weekly sales of cold drinks from the stores were 505 bottles per store. After advertising campaign, the weekly sales in 14 stores were for a week are 609, 699, 580, 595, 622, 694, 580, 543, 543, 654, 589, 720, 441 and 671 bottles. Was the advertisement campaign successful? Assumed level of significance is 5%. Okay, so alpha is equal to 5% means 0.05. Okay, 0.05, 5%. So 80 is mu is equal to 505 and mu is greater than 505. So here if H0 advertisement campaign is not successful, if it is same as 505, if mu is more than 505, then advertisement campaign is successful. Okay, now it is for successful. Okay, now sample size n is equal to 14 given. Okay, now from the given data we calculate the sample mean and sample standard deviation. So the sample mean is, we have to calculate sample mean. So after calculating the sample mean, the sample value is 610 mean and standard deviation is 74.88. Under the null hypothesis H0, the test statistic is x bar minus mu a is by square root of n. So 610 minus 505 by 74.88 divided by 14. Okay, because 14 number of data are there. If you solve it, the value is 5.2467. Okay, now we have to calculate the theoretical value. So it's a right tail test. Since it's a right tail test, okay, the figure will be, so T alpha n minus 1 alpha, so alpha is 0.05, in total number in 15, so 15 minus 1 14. Okay, now we can see the theoretical value or the table value. Alpha is equal to, n is equal to 14, degree of freedom is 14. Okay, so it is 14. Then we have to see the table value. So table value is 1.761. okay, 1 point table value is 1.761. Our theoretical value is calculated value is 5.24, so somewhere here, so this particular value is here, so 5.2467 is here, so we have to reject the null hypothesis. Okay, so our conclusion is what? Reject the H0. That means reject H0 means what? The campaign is successful. Okay, next, third, a machinist is making engine parts with diameters of 0.7 inch. A random sample of 10 parts shows a mean diameter 0.742 inch with a standard deviation of 0.05 inch. Compute the statistic you would use to test whether the work is meeting the specification or not. Okay, so given our mu A is equal to 0.7, sample mean is 0.742, standard deviation is 0.04, and sample size is 10. Clear? Now null hypothesis, mu is equal to 0.7, alternative hypothesis, mu is not equal to 0.7. Okay, now we have to solve this particular problem. So we have to calculate the t statistic. So the t statistic is, so under null hypothesis, the t statistic is x bar minus mu A is by square root of n. X bar is what? Sample mean 0.742 minus 0.7, S is 0.040 by n is 10. Okay, so square root of 10, and the calculated value is 3.32. okay, now it's a two-tail test, so we have to identify the table value. T alpha by 2 n minus 1 0.025, n is equal to 10, so 9. Okay, so already you know, if n is equal to 9, degree of freedom is 9. Okay, and alpha is equal to 0.025, so 2.262. So 2.262. okay, and here it is minus 2.262, and our calculated value is 3.32. Since our calculated value is more than the upper critical value, this is upper critical value, hence we reject the null hypothesis. Okay, that means this mu is, reject the null hypothesis means mu is not equal to 0.7. The heights of a 10 males of a given locality are found to be 70, 67, 62, 68, 61, 68, 70, 64, 64, 66 inches. It is reasonably believed that the average height is smaller than 68 inch. Assume alpha is equal to 0.05. So alpha parameter of interest, mu, height. Okay, alpha is equal to 0.05, 80, mu is equal to 68, h1, mu is less than 68. Clear? Sample mean, so we have to calculate the sample mean. Sample mean is 66. We have to calculate the standard deviation. Standard deviation is 10. Okay, and under the null hypothesis, state statistic is so t cal x bar minus mu s by square root of n. X bar is 66, mu is 68, s is 10, square root of n is um, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 10 and the value is minus 2. Okay, now it's a left tail test. For the left tail test, minus t alpha in minus 1 minus t alpha is 0.05 and it is 9. Okay, and its value is, you can see here, if alpha is equal to degree of freedom is 9, if degree of freedom is 9 and alpha is equal to 0.05, it is 1.833. okay, so the value is minus 1.833. okay, and your value is minus 2, so minus 2 will be somewhere here. Since the calculated value is smaller than the tabulated value, hence reject the null hypothesis, and we conclude that the average height is smaller than the 68 inches.